Hello and welcome to helpyourmath.com. In this video, we are going to look at an example of solving a quadratic equation using the quadratic formula. A quadratic equation is of the form ax squared plus bx plus c is equal to 0. We usually use the quadratic formula when the trinomial that we're given is not factorable, but you're welcome to use it even if it is factorable. And the quadratic formula, just to review, is x equals the inverse of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. That will tell us the zeros. That will tell us what would make this equation true. Let's take a look. Okay, so we're given x squared minus 2x equals negative 13. Just to review, the quadratic formula is the inverse of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. What I notice is that this is not set equal to 0 the way this one was. So the first thing I want to do is set it equal to 0. Right now I have a negative 13 that's all by itself. So I think I'm going to make that side the 0. I'll add 13. So that way this side becomes a 0. And then I'm just going to put these in order. We have x squared minus 2x plus 13 is equal to 0. I could check to see if it's factorable. We're welcome to use quadratic formula for things that are factorable, things that are not. This particular quadratic is not factorable anyway, so we'll jump right into quadratic formula. A is the leading coefficient, the coefficient in front of x squared. Since we don't see one, it's going to be a 1. B is the coefficient of the middle term, so it's going to be minus 2. And C is going to be the constant, it's going to be positive 13. We want to make sure that A, B, and C, this is when the quadratic is set equal to 0. We don't want to use the original one with the negative 13 because that's going to give us an incorrect result. And now we're going to plug in and then we'll simplify. So we have the inverse of negative 2, or negative of negative 2 would be just regular 2, plus or minus, I'll say x equals. And then under the radical, this is called the discriminant b squared. We want to make sure if you're using a calculator that you're putting the negative 2 inside parentheses. Otherwise, you're going to get a negative that doesn't belong because it should be positive. We're squaring something, it turns positive. All divided by 2 times 1. Okay, we have a little bit of cleanup outside the radical and a lot of cleanup under the radical. Minus 2 squared, that's 4. And then 4 times 1 times 13. There's only one negative, just that one subtraction. So this will be subtraction. And then this will be 52. All divided by 2 times 1 is 2. We want to keep simplifying under the discriminant. I know it's really tempting to be like, look, we have 2 2's, cool. But we can't actually simplify those yet because we have 3 terms all combined in this one example. If you want to split them up, cool, you can split them up. But I'm not going to. I'm going to keep them like this for now. We're going to keep going here. We have the square root of negative 48, so we do have complex roots. And now I'm just going to kind of pull the minus 48. First, I'm going to think about it as minus 1 times the square root of 48. And then I know, since it does say complex numbers, we're going to keep going with this. The square root of negative 1 becomes an I. The square root of 48, I'm looking for the largest perfect square factor because 48 itself is not a perfect square. It does have a factor, this one's kind of a kicker, it's 16. It also has 4, which is fine, but then you'd have to do 2 steps, whereas if we use 16, we only have to do 1 step. So I'm going to think of 48 as 16 times 3, and then the square root of 16 is 4. Keep reading this I, so I'm going to put the 4 with the I, and then the 3 stays under the radical. So that's all stemming from this square root of minus 48. So this is all the work I have for that, just kind of showing it all in one place. Now I'm going to replace the square root of negative 48 with that top thing with the 4i root 3. And we're going to get x equals 2 plus or minus 4i root 3 divided by 2. Now all 3 terms are divisible by 2, so now we can divide by 2. 2 divided by 2 is 1, plus or minus 4 divided by 2 is 2i root 3. Divided by 1, the divided by 1 we don't need. The plus 1 at the beginning we do, divided by 1 we don't. So when I go to write my solutions, I'm going to split them up into 2 solutions because there are 2. The plus or minus means plus or minus. And I'm going to drop the denominator because divided by 1 is not going to change anything. So I have 1 minus 2i root 3, and I have 1 plus 2i root 3. This has been an example of using the quadratic formula to solve a quadratic equation. Thank you for stopping by.